Hi everyone, I'm Brock. We are Team Dawn. Thanks for watching our presentation video. The open source project we research on is a 2D web game engine. Firstly, we will quickly introduce our team members, and then we will introduce the functional requirements and non-functional requirements in our implementation. Then we will introduce the architecture. Since we already introduced the original architecture during our design presentation, in this video, I will mainly focus on the additional features we have implemented for G4. Then, I will go through some source code to help you to better understand how those functions work. In the end, I will run the demo for you. This open source project is led by Professor Kevin in University of Washington. The team members are Brock, Chloe, Luo, and Abdul. Our advisor is Professor Haseline. The first functional requirement we implement is a health system. So as you can see, there are 5 right hearts above the hero. It means the hero has 5 points of health. If the hero was hit, he will lose 1 point of health. If he explores 1 treasure, he will recover 1 point of health. When his health becomes 0, the game is over. The second functional requirement we have is a treasure system. As you can see, here is a treasure box. When the hero explores the treasure for the first time, his health will increase by 1 point. But once this treasure box is already explored, when the hero is trying to explore it again, nothing will happen. This is multiple system component. As you can see, there are 2 heroes. You can use A key and the D key to control the first hero and use the left key and the right key to control another hero. So 2 friends can play this game together. And the last functional requirement we implement is a hero bullet system. As you can see, this is a bullet emitted by the hero. It can destroy the enemy. Then let's go to the non-functional requirement. The first non-functional requirement we implement is reusability. As you can see, we implement 4 features, and all those features are implemented in different classes. And all those features, because this is a game engine, it can support many different games. So if we want to use these 4 features, the classes we create in this game can be easily reused in another game. The second non-functional requirement is user-friendly. As you can see, there are 2 states of the treasure box. When the treasure box is never explored, it will be a full box. Once it's explored for the first time, it will be an empty box, so that the player can easily understand whether this treasure box is still capable to increase health or not. The last non-functional requirement is scalability. As you can see, there are 2 players, and their location is updated in the file-based database in real time. This is player 1, this is player 2. It's very easy to scale into more players. Moreover, for the sake of time, our current multiplayer component only supports local gaming, but it's ready to scale to support online gaming in the future. This is architecture for the game engine. We already introduced the original architecture in the design presentation. And here, I will focus on the 4 additional features. So as you can see, this is a component of health. This is the corresponding connector. This is a treasure component, and these are the corresponding connectors. This is a hero bullet component, and this is a connector. The last one is the multiplayer component, and these are the connectors for it. So in the architectural diagram, we can easily see what has been added to the original system and how our new additional features align with the original system, so that we won't suffer degradation of the architecture. And here are some design changes in G4 compared with G3. For the hero system and treasure system, we don't have too much change. For the hero bullet system, we inherit the system from the particle class in G4. As for the multiplayer, the main change is that this component is partially completed, because if we want to fully synchronize the whole game scene, it will cross hundreds of lines of code, which is beyond the expectation of G4. Then let's look at some key source code. All 4 components are written in JavaScript because the original game engine is based on JavaScript. As you can see, this is a basic construction for the health system. It extends from the game object class from the original game engine. The method build spread gets the position of the texture from the resources, and the method set position is to determine where to draw the right heart. And the second one is the treasure system, which shows 3 main methods for the treasure. The method build spread is similar to the build spread in the health system. It is to get the location for the texture. The method press treasure is triggered when the hero explores treasure. The method get treasure state is to change the treasure state so that we can change how it looks like. And then is the hero bullet. It extends the hero bullet. It extends from the particle classes from the original system. And the main function is to shoot the bullet. And when the bullet collides with the enemy will be destroyed. The last component is a multiplayer system. We utilize file-based real-time database. Firstly, we add the file-based configuration file into the index.html. And then we need to define when we need to build a reference in the hero class. Also, we need to update the hero class so that it can update hero's position accordingly. In the end, we need to create a new class called KeyPressListener. The main function of this class is to listen to the movement of the hero and update it in the database real time. Okay, let's look at the demo. We have deployed our game on a public website. You can play it directly from this link, or you can download our source code and run it locally. If you want to run it locally, first we need to open the index.html and open the live server. For Mac, the hotkey is to press Command key and Command L at the same time, and then press the Command key and key O at the same time. Then the game will be launched. As you can see, this game is initialized locally, and this one is deployed in a public server. Let's play it. When I move key A and key D, I can move the first hero. When I move the left key and right key, I can move the second hero. And you can see this is how the treasure box looks like when it's not explored yet. And now I will try to exploit. You see my hero increased health by 1 point and the treasure box is empty now. And when I was attacked, I will lose 1 point of health. And I can press K to attack the enemy. So when the enemy is hit, it will be destroyed. Then let's have a quick look at the source code in the editor. This is a class for the treasure system. This is a class for the health system. And this is a class for the hero bullet. And the last one is the key price listener designed for the multiplayer component. They are called in the game level 1.js. As you can see, when a collision is detected, we will update the hero health. As for the treasure, we will detect the collision between the hero and the treasure. Also, we need to verify the treasure state so that the hero health will only increase when the treasure was explored for the first time. As for the hero bullet, we will detect the collision between the hero bullet and the enemy so that we can destroy the enemy when the hero bullet hits the enemy. As for the multiplayer feature, it's more complex. Firstly, we need to add the file-based configuration into the index.html as a root directory. 3 scripts, including file-based app, file-based auth, and file-based database, are imported to facilitate the usage of file-based library. The file-based config object contains information about our file-based project, including the API key, auth, domain, database URL, and other unique information. The object is passed to file-based.initialize app to initialize the file-based services in our app. Secondly, we need to create the key price listener class to better support data transfer between our game and the file-based database. This class can be extended to support various types of games that require event listeners for the multiplayer feature. At the end, we added file-based refer with the constructor of the hero class. This allows file-based to access and manipulate the data for a particular hero character. This file-based refer is later used in the update function. to synchronize the hero's status with a file-based database. In this video, we demonstrate how the database change. Currently, we have 4 attributes that synchronize with the database. The health of the hero, the moving direction of the hero, and the X and Y coordinates of the hero. When the user presses a key, the input is handled locally. To update the character's movement, the game then sends updates to Filebase, including the character's current position and other game states. Other devices running the game receive these updates from Filebase and update their own game state to match. This feature is not completed, and we are unable to show the synchronization between different devices, due to the fact that this game was designed for multiplayer features. Fully enabling synchronize the whole game scene will require significant change to the original game with hundreds of lines of code. That's all for the four new features we have implemented. Thanks for your time. Any questions?